So this is a video for the first part of Chapter 13 Notes, Sampling Distributions on Proportions, Part 1. So let's just start with what a proportion is, just to remind ourselves of that language. A proportion is a percentage or fraction of a group. And that's pretty much all it is. But in this case, we consider it to be kind of like success versus failure. So a proportion or a fraction, a percentage or a fraction of a group of individuals or subjects who answer affirmatively. Oops, I can't spell. Affirmatively. There was a yes or no question and they said yes. Okay? So we have two different proportions that we think about, and we're just going to discuss the very first one, which would be for the population. So the population proportion is also expressed as lowercase p, which, if you remember from the videos for the binomial model, this is equivalent to the probability of success. But in this case, this is the percent of the population who basically said yes to a yes or no question, right? We want to know how many people said yes or were successful out of the total number of people. So if we have a population proportion P, then just to clarify, if these are people who said yes, then this means that we would also know that the people who said no would be the complement, right? So these are still going to be the same letters, P and Q, that we use in this chapter, okay? Population, proportion, and the letter P. All right, so what is a sampling distribution on proportions? Sampling distribution of a proportion. So what is this? This is a model we use to make predictions about population data. About population data, okay? So what are some key features of this particular model, right? So this model is unimodal, symmetric, and it's centered at P, the population proportion, right? Just as a reminder, P stands for the population proportion. So this follows a normal model. Okay? So what does that mean? That means that this picture looks something like this, where P is in the middle, okay? And we compute the standard deviation, which we know there are 3 on either side. Remember this normal model from way back when. So the standard deviation in this case is the distance, the distance between P and this first mark, right? The standard deviation. And that's computed by a little bit of a scary equation. We take P, we multiply it by Q, and we divide by the square root of N. So if it follows a normal model and the standard deviation is the equation that you see there, right? Then what we want to think about here is what's going on with the model as a whole. Like if we wanted to use our typical idea of mean and then standard deviation in using these values in parentheses, our model would have to look like this. P and then P, Q, all over n. And so this would be a normal model where the center is p and the standard deviation is the square root of p times q all divided by n. So, and there's only one other thing that I want to mention, okay? And there are, there's only one other thing that I want to mention in this particular instance, and it's that we typically have this idea of the sample proportion. So sometimes we compare the sample proportion, which we refer to as p hat, to the population. Okay? So when we do that, we think of the sample proportion, p hat, as equal to the number of people basically who said yes. So we refer to these people as the number of successes divided by the number of subjects, right? Or let's actually replace that with the more typical phrasing, sample size, and we'll be consistent using n as sample size for the remainder of the unit. So it says sometimes we compare the sample proportion p hat to the population, and in doing so we might express it as a fraction, which we can then can always be written as a percent or decimal, right? We could convert this into a percentage or a decimal, okay? And so the functions that we will need to use here in terms of looking at a sampling distribution problem, if we're looking at a problem like this, using one of these distributions, then we would need to think about using normal CDF and inverse norm as our two possible options. And you'll see in the packet that we use normal CDF here for the two problems in the packet. Okay? Keep on watching these videos and making sure you're paying attention to the notes. Let me know if you have any questions.